Welcome back, everybody. In this video, we're going to talk about different ways to show distributions of data. It says which histogram represents the data. Okay, histogram breaks off sets of data into intervals. So you can see from all four choices here, we're going to choose the correct choice here. They all come from 0 to 9, 10 to 19, 20 to 29, 30 to 39, 40 to 49, and 50 to 59. So what we're going to do is count each one that shows up in those intervals and then hopefully find the right match. So from 0 to 9, that would be 1 and 2. So there's 2 tick marks for 0 to 9. So it could be either this one or this one. From 10 to 19, I see 1, 2, 3, 4, 5. So we want to go 2. We want the next one to be 5. Again, it could be the top right or the bottom right. And then in our 20s, looks like there's only 1 in the 20s. And yeah, that looks like the third one here. Yeah. Okay, so I think the top right's going to be the one that fits. Here we have 1, 2, 3, 4, 5. In the 40s, we have 1, 2, 3. And in the 50s, we have just 1. So looking at the right histogram, this goes to 2, 5, 1, 5, 3, and 1. So yeah, this one right here is the correct representation. So that's the correct histogram. Let's look at another one. This histogram shows the number of hours volunteers worked 1 week. What percent of the volunteers worked 8 to 11 hours, or 16 to 19 hours? Okay, let's first go through and look, see how many from 0 to 3. That's 4. Let's make that a little bit thinner so we can see it better. From 4 to 7, 2 workers. 8 to 11 hours, 5 workers. 12 to 15, 4 workers. 16 to 19, 4 workers. And 20 to 23, 1 worker. Okay. First, let's get the total here. 4 plus 2 is 6. 6 plus 5 is 11. 11 plus 4 is 15. 15 plus 4 is 19. 19 plus 1 is 20. So we're out of 20. That's our total. And if you worked 8 or 11, 8 to 11, or 16 to 19, that's 5 and 4. And that makes 9. So 9 out of 20, put that as a percent. 9 divided by 20 is 0.45. And then the percent of that, 45%. That tells us, using a histogram to determine the amount of people in different categories. All right. Another way to distribute data is what's called a box and whisker plot. So here we have a set of data, 12, 10, 16, 19, 18, 14, 4, 18, and 4. First going to put that in order. In order, the data is 4, 4, 10, 12, 14, 16, 2 18s, and 19. There is 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 data points. The lowest being 4, the highest being 19. The middle of that would be the fifth number right here at 14, the median. Right, and then we have what's called the interquartile ranges, and that's like the median of the first half and the median of the second half. So as you can see, we have 1, 2, 3, 4, 5 numbers in the first half, and the middle number there is 10. That's Q, what we call the Q1, the first quartile. Again, it's like the median of the first half and second half of numbers. This one is called Q3. It's the middle of the second half of the numbers, and that would be 18. So the median is also known as the second quartile, Q2. And so now what we're going to do with those 5 values is plot them on the number line. And we'll show you where the box and whiskers come from. All right, let's put a dot at 14 right in the middle, so we know that's the middle of the data. 19 is the highest, the maximum. 4 is the lowest. I will also do the interquartile ranges. I will put those, they call interquartile range, here at 10 and at 18. Okay. So what we're going to do is just make a box around Q1 and Q3. That's where the box part comes. And then put a line going through all of them. And we kind of see the whiskers on the outside. That's what we call the box of whiskers. You can kind of see where the distribution of data. 50% of the data is within the box. 25% of the data is on either side. Yeah, from here. 25% here. That's going to help us in our next problem. And then, yeah, this is the middle 50% of data from here to here. All right. Now, that's box and whisker plot. Now we're going to ask a question based on how data is segregated like that. We're going to look at this situation here where they tell us straight up the 5 values, the min, the max, the median, also known as Q2, and also the Q1 and Q3. Remember, we call those interquartile ranges. Suppose 288 electricians took a certification test that is worth 140 points. The 5-number summary for the scores is shown here. How many electricians had a score of 110 or less? 110 or less is right here. And then we go up from here. So that's quartile 1. From here to here is 25% of the data, just like we saw in the previous graph. Okay, so we had 288 electricians, and we want to know a fourth of them were 110 or less. So how many of them? Let's multiply by 0.25. And if you use your calculator, 25% of 288 is 72. That's our answer. About 72 of them, 72 members of the electricians had 110 or less. So this is quick. Now you can ask questions about it. If they wanted to know, how many had 125 or less, could have done the 50%. Here's 75% of the data is at Q3, and obviously 100% of the data is all from the min to the max. Okay, look at another one here. Another way to display data is using what's called a dot plot. Dot plot simply is just like it sounds. You use dots to represent the frequency of data occurring. We got a table here on the right, and we're going to make a dot plot here on the left. Sherry recorded how many miles she ran each day in this table. Create a dot plot for the data in the table. All right, so how often did she run 3 miles? Just one time. Make a dot there. 3.5 miles, she did 2. And notice how I stack it evenly. She did 4 miles 3 times. She did 4.5 miles 3 times. 5 miles 2 times. And 6 miles 1 time. So we kind of see, it's like a visual representation of how the data literally stacks up. It's called a dot plot. All right, so now we talked about different ways to show the data. We looked at histograms, box and whisker plot, 5-point number summary, and this is the dot plot. Thank you very much for watching.